and right on time. Well, we're going to get started. It's 10:30. We're probably going to have a few more that join us here in the short term, but let me first thank everybody for joining us for today's conversation, the long coffee break, the changing state of variable frequency drive. Just a few things to note. This is recorded, so this will be available to you after the fact. We'll send out a link. You can certainly forward that on to others who you might think be interested in the information. This is a weekly series that we are presenting from Long in Utah. We have probably about the next 4 or 5 weeks lined out, and I usually send an update to those the week of after this takes place. So please make sure to take a look for that and hopefully join us in the future when we do other topics that might be of interest to you. I would ask that you hold questions until the end of the presentation. If you do have a particular question, please put it in the chat, and then as we're finished up, I'll get all that information over to our speaker today, Jim Wilson, who is with Yaskawa, and then we'll handle those questions as we go along. Jim is joining us from Colorado Springs. I've known Jim for a long time. He's my guru. If any of you think I know anything about variable frequency drives, well, it's because of Jim Wilson. So he'll be doing the heavy lifting today. And one thing I've noticed in the recordings is that I say the word a lot. So I'm going to try and not do that as we move forward, but you guys might keep the count on me down as few as possible. It's interesting when you go back and try and look at the presentation that you've given, some of the things that you see and the cringeworthy effects. So if you have any other ideas about how I can do my job better, either with presentation or how we present information to you in general, or other items that you might want to see us cover in future lunch and learns or coffee breaks, please feel free to get me that information and I'd be happy to help. So given that, Jim, if you are ready to go, we are ready to start.
Well, thanks, Jeff, and thanks to Long, and thanks to all of you for coming. I've been applying variable speed drive since 1984, so I've been a witness to the evolution of the product, and that's kind of the basis of the presentation. You know, it helps to understand where we've come from with variable speed. I mean, we started off with horsepower to steam. Edison came up with the first little DC motor. I've actually been in a handle plant that was powered by a water wheel with this jack shaft, and they changed the speed of the machines based on these pulleys. And then, of course, we came up with a crank style to be able to change the diameter on the pulleys and change the speed. Our first variable speed, electrically speaking, was DC. And there were a couple other designs too, eddy current clutches, Bayer variator. Believe it or not, there really was a Bayer variator. It was discs that rode together in a viscous liquid like an automatic transmission, and you move the disc in and out to change speed. DC, these motors were very expensive. They had wound rotors and stators. They were expensive. If you ever lost, they required tachometer feedback. If you ever lost the tach, they could go into a runaway mode and just keep accelerating until they physically disintegrated. And of course, DC power is much more, high voltage DC power is much more dangerous to handle because unlike AC, it never crosses zero to give you a chance to get off that line if you're in contact with the conductor, and very, very poor power quality. So this is where I started, 1984. This is actually one of the first drives that I applied. Note there's a run button and a fault button, no keypad. Everything was hardwired in analog, and this is just a 1 horsepower. It was primarily for speed control, and it ran standard AC induction motors, which was very attractive. And to program it, there was a board in there. I don't know if you all know anything about the old phone systems. You've seen the movies with the switchboard operators. That's kind of how you program. You had a board with a bunch of holes. You had to look at a book, and then you literally took wires and would put in one hole and then connect it to another to get the drive to do what you wanted to do. And the early drives used the same power switching devices that DC did, so the power quality was really poor. Back in those days, I had a 15 horsepower demo to take to customers, and it was literally on a trailer that I towed behind my car. So, but things did get better with time. In the 1990s, we developed pulse width modulation. Actually, it was developed in the 80s, but it took to the late 80s into the 90s to get into the marketplace. And that was because of giant transistor technology, and we dramatically improved power quality and drive performance. In the 90s, we had displays with single lines. You had to have a manual to program it, because the program parameters, they were all N001 through N00 or N400, and they were not grouped. You couldn't do anything with this drive without a book and spending some time on it. So the 2000s, the E7 drive, this was the first drive in the marketplace that was specifically designed for commercial HVAC. It wasn't just an industrial drive with, somebody waving a wand over it. It was programmed from the ground up for commercial HVAC. It only had a 2-line LCD display, but it reads in English statements. And when we grouped the parameters, so if you needed to adjust motor parameters, well, you went to that group. They were all together. And we've actually never changed that grouping. 2012, the Z1000 came into the market, much better display, 5-line alphanumeric. English statements, engineering units. We added a real time clock so that you could time and date stamp faults or alarms, and you could even change the set points based on the time of day for those smaller applications where you don't have a building automation system. And we added maintenance monitors to eliminate spare parts. So now you can go look at the drive and see what parts are getting some age on them, and you ought to take a look at possibly getting one on hand or be ready for that event. Today's modern VFDs, we just this last year launched the HV600. We've made huge advancements with the keypad. Of course, it's still got the HOA. There's a USB connector here, and I'll tell you why that's important in just a moment. We put an LED status ring. So if you've got a bunch of these in the control room, one peek in the door and you can tell, well, am I running? Am I ready to run? Or is there something wrong with it, with a red light that drive needs attention? We put the network status LEDs visible because almost all drives are connected to networks these days. We put the ratings label on the front. So, with the ratings on the side, sometimes those are hard to get to. And the all important QR code. You can, I don't want to steal my own thunder, but we now have smartphone and tablet programming. You can walk up to a drive and scan that QR code, and with using Drive Wizard Mobile, it tells you everything you ever want to know and then some about that drive. This new keypad, it's got a menu-driven startup. Even though we still ship a user manual, you don't need that manual to start this drive. You go to the application that you're using, and it asks you questions to answer to get this drive up and running. You can customize the screen with up to a dozen different parameters, or you can use bar graphs, analog gauges, or if you want to trend a parameter on that display, you can set that up as well. The real-time clock, it has more functionality now. Not only does it time, state, damp faults or alarms, but it also tells you the time and date if someone changes the program in the drive. So that can be a pretty powerful tool. And the 32, we now added the keypad. You can put a micro SD card in to automatically, continuously trend certain parameters. The way we used to have to do it is if you had a problem and we needed to trend, those monitors, we'd have to leave a laptop in the panel and then, overnight and then go back. And it was kind of the luck of the draw if the problem occurred again. Now, I was talking to an oil and gas customer. People smarter than me about this stuff. And they came back to me and said a 32 gig card would record about 15 years worth of data. So you can use less expensive cards, maybe an 8 gig or a 16, and still get great performance. We have the mobile Drive Wizard now for smartphones and tablets. You can actually program a drive without power. Now, this only works with Androids, and I'll tell you why in just a minute. It has to do with Apple licensing and the exorbitant amount they want for cabling. But with an Android device, and why is that important? Well, if you get a spare, you can go ahead and set it up for the application in the box. So in the event you had a problem, that drive is ready to go, plug and play. And we've added Bluetooth wireless. So there's now a Bluetooth wireless option for the keypad. And this is to deal with arc flash. If you have a big drive, maybe in a panel, the keypad's not on the door. Well, you want to open that panel up, you've got to suit up according to OSHA. This allows you to access that drive, everything you can do with a keypad on a smartphone or tablet wirelessly. And then I think I mentioned earlier, we added the bar graphs, analog, and trending plots to the keypad as well. You know, the future of drives in the early days, all we had to run were induction motors. And then permanent magnet motors came into the marketplace because of their efficiency, where they actually, save energy over an induction motor because you don't have to magnetize the rotor with line power. And now we have synchronous reluctant motors coming into the marketplace. So our drives run the motors of today and they run the motors of the future. So, you build a drive with a 28-year mean first failure. Well, it's not any good if you can't, drive the motors of the future. And there's also advanced auto tuning for energy savings. I mentioned Drive Wizard Mobile. All of this software I'm talking about is no charge. You can download it for free. Actually, the QR code in the end of the box, when you walk up the cardboard box or the drive, it will give you a link to put this free software on your mobile device. You can do drive registration, program without power. We already talked about the optional Bluetooth, monitoring, troubleshooting, anything you can do with that keypad, you can do with a smart device. And note, we've got Apple up here now because with the Bluetooth keypad, you can actually use your Apple device, and there is a Drive Wizard version for that. There's still, we still have the Drive Wizard HVAC, a very powerful PC tool. And we've been doing this for many years in the industrial side of the business. You come up with a function that we did not think of in the programming, well, do it yourself, write your own. This is identical to PLC function block programming. So got something you want the drive to do we didn't think of, well, set it up to do what you want it to do. We've added enhanced pump control for constant pressure, liquid level, or constant flow. This is actually a product, the software comes from a product that we've been doing for a long time in the irrigation industry. You can multiplex right out of the box where you can still be connected to BACnet in your building automation system, but you run a single 2-wire conductor between the drives. You can set this network, multiplexing up network, menu driven in 15 minutes or less. It's very quick and easy to set up. And since BACnet has become so popular, the controls guys are going to love this. We've given them a lot more information out of the drive. One glance can tell you, how healthy your BACnet system is communicating with the drive. So the control guys are really going to love that. And we still, we kind of started the trend for having an HVAC commercial specific product. Wherever you want to mount these drives, it's okay. We've got a package for it. So wherever you need to put the drive, we've got a package to handle the environment. And if you really want to talk about the future, pay attention to this. Direct AC to AC conversion. This is coming like a freight train. We were the first to put it into the market. It gets rid of the harmonic issues near unity power factor. It's more efficient, and it reduces bearing currents, and you don't have to worry so much about long motor lead links. And what I didn't mention earlier, all the way back to the 1990s, once we changed that programming structure, it does not change between drive platforms. So if you knew how to drive, how to program a Yaskawa in 1990, the program parameter layout is the same. So it'll look and feel familiar. So that's what we do at Yaskawa. We feel like our job is making the complicated simple. Jeff?
Well, thanks, Jim, for all the information. Of course, this just touched the surface of what we can talk about when it comes to VFDs. Not only options that you're going to see, not only from this new Yaskawa HV600, but these options are pretty prevalent across the larger manufacturers of VFDs that we see in the industry. So you're going to see more and more of this, and its function is ever increasing. So what's the takeaway from the presentation today, the thing that would like you to remember the most? Well, as a story, I remember in 1983, my father brought home the Commodore 64. It was a brand new thing. It was awesome. It was great, but it certainly had a bunch of limitations. And if today I would treat computers the same way as what I thought about that Commodore 64, I wouldn't be using computers much. The point being is that there's been an evolution of drives ever since the 80s and 90s, and it's been a huge evolution, a huge change, and it's very synonymous with what we see in the computer industry. So if you have some misgivings, some issues, some harmonic questions that may be derived either from yourself or from your compatriots thinking about 1980s and 90s technology, well, I would offer that you would probably want to spend a little bit more time updating yourself to what is available today, not only through standard drives like the HV600, but also those that was mentioned at the end of the presentation, the Z1000Us. We've come a long way, and just keep an open mind to that. And I think that you'd be pretty surprised at what VFDs can do and their associated costs and the savings that we can get out of them. They're fabulous pieces of equipment, and we only use them to a very small extent in HVAC. They're used throughout the world in many different areas. At this point, if you have any questions, please type them into chat, and we'd be happy to talk about it. But one thing I do want to touch on that Jim said is that there is an ever-changing world also in motors. There's developments like EC motors, permanent magnet motors, and a lot of future-looking companies like Yaskawa make sure that their units are compatible with those increased stages or those changes as we move forward. So. Also, at this point, too, I'm going to stop the recording. We certainly can take further questions. If you have a particular project you'd like to work on or any further comments, let us know. And also, if you do want to schedule a time with a long employee in order to go over any of these specific categories in greater detail, we can do that for sure. So please get in touch with us. And I do thank everyone for their time today. Have a great one, and we'll talk soon.